Hello friends, in this lecture we will see the basic current voltage relationship of the transistor. Here we consider the basic DC characteristic of PNP and NPN bipolar transistor. So one has to know how the transistor is denoted. So as we know, the transistor is three-terminal device, that is, it consists of three different regions, that is either PNP or NPN transistor. So in case of PNP transistor, there are three different regions. This is a P region which is heavily doped, so indicated as P++. This is a N region which is moderately doped, so it is indicated as N+, and this is a P region again which is lightly doped, so it is indicated as P. So this first heavily doped region is emitter of the transistor. So here the current is IE. Current flowing through the emitter terminal is denoted as IE. This is a base which is moderately doped, and the current flowing through the base terminal is IB, and this is the collector terminal. So the current flowing through this collector terminal is denoted as IC. So this is a PNP configuration of transistor. Then we will see the NPN configuration. So similar to PNP transistor, this N region is heavily doped, so it is denoted as N++. This P region is moderately doped, so it is denoted as P+, and this N region is lightly doped, so it is denoted as N. So as this is the emitter, so current flowing through emitter terminal is IE. Current flowing through this base terminal is denoted as IB, and current flowing through collector terminal is denoted as IC. And again we will see the symbol for this PNP as well as NPN transistor. So this is figure 1, which shows symbol and nomenclature. Symbol and nomenclature of the transistor. And here we will draw the symbol for NPN transistor. symbol and nomenclature of PNP and NPN transistor. This is figure A, shows symbol and nomenclature of PNP transistor, and this figure B shows symbol and nomenclature of NPN transistor. PNP and figure B, NPN transistor. So the arrow which is inward in case of PNP transistor, and this arrow which is outward in case of NPN transistor indicates the direction of current flow under normal operating condition. That is, for the normal operating condition, the emitter junction is forward biased while the collector junction is reverse biased. That is, this junction, emitter base junction is forward biased and this base collector junction is reverse biased. Similar is the case for NPN transistor. The transistor can be connected in 3 circuit configurations depending upon which lead is common to input and output circuit. So we will see the 3 different configurations of the transistor. So for this different configurations we will use PNP type transistor. So this is emitter terminal. This is base terminal and this is collector terminal. So here current flowing through collector terminal is IC and current flowing through the base terminal is IB. And as this base terminal is common to input as well as output, this configuration is common base configuration, as this base terminal is common to input as well as output, and between these two terminals, that is emitter terminal and base terminal, the voltage will be denoted as VEB. The potential difference between these two terminals, that is emitter terminal and base terminal, is VEB, and the potential difference between collector terminal and base terminal is denoted as VCB. So this is figure A. Then we will see the next configuration, which is common emitter configuration. To which emitter terminal is common to input as well as output. So this is emitter terminal, this is base terminal. So here current flowing through base terminal is IB and current flowing through emitter terminal is IE, and current flowing through collector terminal is denoted by IC. Here the potential difference between base terminal and emitter terminal is given by VBE, and the potential difference between collector terminal and emitter terminal is given by VCE. So this is figure B. Then next we will see the common collector configuration, in which collector terminal is common to input as well as output. This is base terminal and current flowing through base terminal is denoted by IB. Current flowing through emitter terminal is given by IE, and current flowing through collector terminal is given by IC. As collector terminal is common to input as well as output, this configuration is common collector configuration, and the potential difference between base terminal and collector terminal is denoted by VBC. And the potential difference between emitter terminal and collector terminal is given by VEC. So this is figure 2, which shows three configurations of PNP transistor. That is, figure A shows the common base configuration, figure B shows the common emitter configuration, and figure C shows the common collector configuration. Again we will see the figure 3 for the PNP transistor. Which is operating in normal condition, that is the emitter base junction is forward biased and base collector junction is reverse biased. So this is P region, this is a N region, and this is again P region. This dashed line shows the depletion regions at the junctions. So this is emitter, this is base, and this is collector. As this emitter base junction is forward biased, this positive terminal is connected to P region and negative terminal is connected to N region. And again this base collector region is reverse biased. So in this case the N region is connected to positive terminal of the battery and P region is connected to negative terminal of the battery. So this is VEB and this is VBC. This is figure A. Again we will draw the figure B, which shows the doping profile of this transistor. So on the y-axis I denote ND-Na, that is density of donor atoms or acceptor atoms, and on y-axis distance, on x-axis distance. So this is x. So this width is WE, that is width of emitter. This width is WB, which is width of base, and this is the width of collector, which is given by WC. So here this is the depletion region across the junction, which is in between emitter and base. And this is the width of depletion region across the base and collector region. So this boundary is denoted as XC. This boundary is W. This boundary is denoted as 0, and this boundary is denoted as minus XE. So this is figure B, which shows the doping profile of the PNP transistor. Then we will draw the diagram, that is band diagram of the PNP transistor. Under normal operating condition. So this difference between the Fermi energy levels at this N region and P region is given by voltage VEB, and the difference in the Fermi energy level between N region and P region, that is base and collector, is given by the potential VCB. So this is figure C, and this is figure 3, which is in this figure 3. Figure A shows the schematic of PNP transistor connected as an amplifier with common base configuration. Figure 3B shows the doping profile for the transistor with region of uniform impurity density, and the figure 3C shows corresponding band diagram under normal operating condition. The normal operating condition is that in which this emitter base junction is forward biased and base collector junction is reverse biased. And as this is the junction width, and it is seen that this junction width for this base collector junction, it is more wider towards the P side than the N side. It is because the doping concentration of the P side is much lower than that of the N region, and the depletion region becomes wider towards the low doping side than the high doping side. So here the depletion layer width is larger in the P side than in N side. The static characteristic can be readily derived from PN junction theory. To illustrate the major property of transistor, we assume that the current voltage relationship of emitter and collector junction is given by ideal diode equation. That is the effect due to surface recombination and generation. The series resistance and high level injection are neglected. So this effect can be considered later.